Hi, I'm Ariana.
I'm Tarun.
I'm David.
And our project was a real-time animated effect maker, or cartoonifier. This cartoonifier takes input from an NTSC video camera and cartoonifies each frame of the image to create a real-time cartoon effect for VGA output. In order to do this, we did two separate processes, an edge detection and a color reduction. Both of these processes were done in parallel on a pixel-by-pixel basis.
Hi, I'll be describing how we're storing the process data and the source data for our project. So we have two ZBT banks, ZBT Bank 0 and ZBT Bank 1. ZBT Bank 0 is used to store the camera input from the NTSC camera, and ZBT Bank 1 is exclusively used to store the processed pixels. So currently what you're seeing is the camera input. So you're just seeing the ordinary image where as if you're seeing directly from the camera. And what the idea is that whatever's stored in ZBT Bank 0, the original pixel, takes some time to process, and then after a certain latency, it will be stored in ZBT Bank 1, and the VGA module will read whatever is stored in ZBT Bank 1.
So for the color reduction, we take in an RGB pixel from the NST source video, and we use a mask to set the least significant bits of each color of each. We first convert the RGB pixel to the HSV space. Then we use a mask to set the least significant bits in both the H, S, and V spaces to 0. We've added a user input so the user can decide how much reduction they want for each of these spaces. We then convert this pixel back to RGB and send it to the VGA output. Additionally, we implemented a brightness and contrast filter, which brightens up the image, which we think gives a better and more cartoonified effect.
So we also implemented the edge detection, and we have done this by using the Sobel algorithm. So for the edge detection, what it does is it takes a 3x3 block of the image and it convolves it with a kernel, a 3x3 kernel, a horizontal kernel and a vertical kernel. And after convolving it with the kernel, it does a gradient calculation on that, and based on that, it determines if the pixel value is an edge or if it's not an edge. So after doing that, after doing the calculation, it also thresholds the value, and at the end, if the pixel is an edge, it makes it more bold, and that being said, we know that that pixel is an edge. And the output of the module is also a select bit which goes to the image fuser, which David will describe in the next part. And this is a 3x3 output. We see that the edges are clearly described. And we also implemented a 5x5 Sobel using a 5x5 kernel. And this is the 5x5 kernel, and it's a better edge detection than a 3x3.
From using the select bit that comes out of the edge detection, what we have is the fusion of the color reduced pixels and also the edge pixels. So from the select bit, we select the edge pixels over the color reduced pixels to highlight the black edges. And we can also see the edges taking on priority by seeing the difference between the Sobel 5x5 and the Sobel 3x3. And this is all stored in the ZBT Bank 1 and is read from the VGA.